So see, ethanol dissolved in water. Is it audible now? See, liquid, when we are adding liquid in liquid, see here, liquid solution we are having ethanol dissolved in water. That means ethyl alcohol. What is the formula of ethyl alcohol? C2H5OH dissolved in water. And the next one is C, solid dissolved in liquid. Example we can take, yesterday I told you sucrose. Sucrose, you know, no? Sugar. Sugar dissolved in water. And what is the third category? Gas. That means here gas is solute and solid is what? Solvent. Since the solid is more amount, we are calling solid solution. Example for this is what? Hydrogen dissolved in palladium. This is called adsorption. Yesterday I told you adsorption means what? The gas gets adsorbed on the surface. That process is called occlusion. So what is the second category in the solid solution? Liquid dissolved in solid. That means you are putting liquid more amount in solid. This is what? Amalgam. What is meant by amalgam? Any metal with mercury is called amalgam. This is the second category in solid solution. And see the third category, solid dissolved in solid. See, we are putting solid with solid. Solid is more amount, and that we are calling alloy. Now, what is meant by alloy, student? It is a mixture of two or more metals. So, these are the 9 categories you have to remember. In JEE mains as well as in NEET, they may ask you questions from matching type. Is it clear? Copy it. Yesterday we did this, and those who joined today, you can copy this. Till now, up to this we completed yesterday, I think so. Up to this clear for all? Now see student. Now today our discussion will be copied everyone. This one yesterday we discussed till this. Now see I am going to next category. Expressing concentration of solution. Right heading expressing concentration of solution. Right subheading, right today's date, heading right expressing concentration of solution. Now see in our topic how to express concentration of solution. Then student you should know what is meant by concentration. You learned this in 11th class in some basic concepts of chemistry. What we define for concentration, student? The amount of solute present in 100 grams of solvent. That means in 100 grams of solvent, how much amount of solute you are dissolving. That is what we call concentration. So what we define for concentration, make a note. Amount of solute present in given amount of solvent. This is called concentration. Getting my point? What concentration is nothing but how much amount of solute is present in given amount of solvent is called concentration. So to express the concentration, we are having total 8 to 9 terms are there. In our syllabus, we are having 9 terms. What are those expressing? See, first one, we are having mass percentage. Might be you heard this mass percentage in 11th class in some basic concepts in 11th you are familiar. And it is shown by the symbol small w by capital W. This is what mass percentage. We discuss one by one. First I list out what are the various concentration terms we have. The second one we are having volume percentage. So volume percentage is shown by the symbol small v by capital V. This is volume percentage. The third one we are having mass by volume percentage. What is the third concentration? Mass upon volume concentration. And this is shown by the symbol W by V. We use in pharmaceuticals. Means might be if you saw the tablet backside they will mention mass by volume. In the pharmaceuticals we express this third one. And the fourth one we are having mole fraction. Mole fraction is shown by the symbol of chi. This is what the symbol we say chi. Mole fraction important. And the fifth one we are having molality. You know molality is shown by the symbol of what? Small m. This is molality. And the sixth one we are having molarity. That is, molarity we see the difference between molality and molarity. This is shown by the symbol of capital M. And the last but one, normality. Normality is shown by the symbol of capital N. And the last one we are having ppm. What is ppm? Parts per million. This is expressed only for small trace amount. What is the full form of ppm? Parts per million. So these are the total 8 ways by which we express concentration. Copy these all 8. We will discuss now one by one. Are you following, students, everyone? So be regular for the classes so that you can understand if your regularity is more important. And see, we will help you. What is the, but from your side, you have to put more effort, students. As I told you, as soon as classes start, daily 2 hours you have to allot for chemistry. So chemistry is a scoring subject. So if you understand properly, you can get easily good score in chemistry. But thing is, you have to understand the concepts carefully, and interaction with the teacher is important. On the day wise, what we teach here, immediately you have to recap. Copy number. Now let us start with one by one. What is the first one? Mass percentage. Now observe here, all of you. Now what is mass percentage? As I told you, this is shown by the symbol of small w by capital W. Now suppose two components are there. Assume component A is present, component B is present in a solution. Are you following? I took two components A and B. Now tell me, student, I want mass percentage of A from A and B. So how do I get C? If I want mass percentage of A, I have to take mass of A upon mass of A plus mass of B into 100. Are you getting my point? So among the two components A and B, if I want to find the mass percentage of A, how I get mass of A by total mass? That means mass of A plus mass of B into 100. Same way, tell me if I want mass percentage of B, student, how do I get mass percentage of B? Same, no? How do I get mass of B component by total mass of both the components, no? A plus B into 100. Hence, what we define for mass percentage, students, amount of solute present in 100 grams of solution. Amount of solute present in 100 grams of solution, that's what we are calling mass percentage. Is it clear, students? So simple, no? So mass percentage is nothing but how much amount of solute is present in 100 grams of solution is called mass percentage. Clear for all? Copy this, write this definition, amount mass percentage, then you write these two expressions. That is mass percentage of B to get what we do, mass of B by total mass into 100. Simple, no? Understood, everyone? This is already you might be studied in first year in some basic concepts. Once again, it is a repetition. Now tell me, students, does mass percentage depends on temperature or will it be independent on temperature? So in exam they ask you which concentration is dependent on temperature. See here, there is no volume term, no? So as volume term is not there, temperature it doesn't depend. So here make a note, mass percentage is independent on temperature. It doesn't depend on what? A temperature. Understood, students? So why it is not depending on temperature, as there is no volume term. The volume term would have been there. There we will have surely effect of temperature. Here temperature has no influence since there is no volume term. So in exam point of view, they ask you which concentration is the temperature dependent or which concentration is temperature independent by giving set of concentration. Clear? Also understood all of you this one? Copied everyone? Now I give you one numerical, write this question related with mass percentage. Simple no students. So mass percentage is nothing but amount of solute present in 100 grams. Now see, write one question to understand. See in exam numerical part I am giving one question. 5 grams of unknown substance. We don't know what is that unknown substance. 5 grams I took of X is present in 25 grams of solvent. Then find the mass percentage of solute. Now see this type of questions we get in mass percentage question understood. What I took 5 grams of unknown substance. See mass of unknown substance is given 5 gram. That is present in how many grams of solvent? 25 grams of solvent. Then what will be the mass percentage of solute is asked. So simple know how you get mass percentage of solute students. See in order to get mass percentage of solute, what would we do? Tell me mass of solute given to you as 5 grams, no? So I have to substitute here 5 mass of solute. I have to take total mass of the solution. What is the total mass? 5 from solute and 25 from solvent. Is it right? So I have to add 5 plus 25 into what? 100. Now simplify this. How much you get? This division on addition of denominator we get 30. This is into 100. So 5 will cancel by 30. How many times? 6 times. No. 5 ones are 5 6 are. Clear? And this 100 upon 6 I can multiply 2 multiple 2 3s are 2 50s are. So remaining what is that denominator? Remaining 50 upon 3. Do division 50 upon 3 in the rough work. So on division of 50 with 3, 3 multiple will cancel. 3 ones are 3, 20, 3 6 are 18. So borrow from this 2 will be there point. Is it coming 16.66 students? See then the what will be the mass percentage of solute? 16.6% is the mass percentage of solute. Clear? Understood all of you? Simple no? So in order to get mass percentage of solute, what we do? We have taken mass of solute by total mass of solution into 100. Clear all of you? Suppose in the same question, what is the mass percentage of solvent would have been asked. The first part we did mass percentage of solute we did no. Now how do we get mass percentage of solvent? So mass percentage of solvent would have been asked. How you get? Mass percent of solvent will be equal to, what is the solvent mass given? 25. 25 by 25 plus 5 into 100. That comes how much? 25 by 30 into 100. So 5 5s are 5 6s are. That is 500 upon 6, or you can subtract from 100 16.6. So this will cancel 2 3s, 2 50s. That is 250 upon 3 students. So divide 250 upon 3, or you can subtract directly from 100 minus 16.6. So that comes how much students? 3 8s are 24. 1 0, 3 3 is 9. 83.3% we get. Correct? This will be mass percentage of what? Solvent. Understood all of you? That's all about mass percentage. So what is mass percentage? Amount of solute present in 100 grams of solution. Will it be temperature dependent or temperature independent? Means it is temperature independent. Why? Since there is no volume term. Clear for all? So we go for next one, volume percentage. Hope to understood all of you. Simple. Second concentration I am going volume percentage. Now see students, volume percentage can be defined similar way what we done for mass percentage. See, previously it is mass, this is in terms of volume, no? And in textbooks you will observe like symbol like this, small v by capital V. That means see what is this? Simple. Same as previous one, I am taking two components, A component and B component. Now among these two component I want volume percent of A. Tell me how do we get volume percent of A, student? Suppose if I want volume percent of A, what should I write? Volume of A by volume of A plus volume of B into 100, no? This will give volume percentage of A component. Correct? Same as what? Mass percentage. Same way, mass volume percent of B to get what should I do, student? Same thing. Volume of B by volume of A plus volume of B into 100. This will give volume percent. So what we define for volume percent? The amount of solute present in 100 ml of solution. Previously mass percentage what we wrote? Amount of solute present in 100 grams of solution. So write definition for volume percent. Amount of solute present in 100 ml of solution. Understood all of you? Saw the difference between mass percentage and volume percentage and copy this relation. Now tell me students, do volume percentage depends on temperature or independent on temperature? Here surely temperature will have influence. Why? Since volume term is there, sure temperature influence will be there. So here make a note, it is temperature dependent. So in mains exam they give you the few set of terms, concentration, and they ask you how many of them are integer type or temperature dependent or temperature independent they are. So here it is in temperature dependent. Why? Since there is volume term. And generally we express this volume term in beverages. Where do we express this? Concentration is expressed in beverages. Beverages means what? You know, beers, champagnes. In beverages, generally we express this concentration. Understood, friend? And see here I am giving one statement, 10% V by V, ethyl alcohol I am giving. So in textbooks you will observe this type of representation. Now tell me what does 10% V by V ethanol means? This is called ethanol. Ethanol is the IUPAC name, common name, ethyl alcohol. Means I have taken 10 ml of ethyl alcohol. To that I have added how many ml water? 90 ml of water. Getting idea? 10% V by V means what? I took 10 ml of ethyl alcohol. To that how many ml water I have added? 90 ml and I made it to 100 ml solution. So understood all of you? Make a note. 10% V by V means 10 ml ethyl alcohol is dissolved in how many ml of water? 90 ml of water. To make it how many ml of solution? 100 ml of solution. Is it clear? Simple, no? Same as mass percentage. Copied all of you. So this is what second term. Write one question related on volume percent. I'm going the next thing. Copy no, all of you, right? See, write one problem related on volume percent. 20 ml of ethyl alcohol. What is the formula of ethyl alcohol? In organic chemistry, people study first year you got no. Ethyl alcohol is CH5H. Is added to 60 ml of water. Then find the volume percent of ethyl alcohol. Question understood, simple. 20 ml of ethyl alcohol I have taken, to that I have added that 20 ml to 60 ml of water. Then what will be the percentage of ethyl alcohol? Tell me, student. So what should be the percentage of ethyl alcohol? Would have been asked. What should I took? Volume of ethanol. How many ml we took? 20. By what is the total volume of the solution? I have to add 20 plus 60, no? That means 20 plus 60 comes how much? 80 of 100. This one simplifying, see, 20 upon 80 into 100. 10 multiple, 10 twos, 10 eights. This 2 1, 2 4. 4 will cancel 100 by 25. So what will be the percentage of ethyl alcohol in that? 25% of ethanol is present, no? So understood, this is what volume percent. Clear, all of you? Simple. So till now concentration we learned, mass percentage we learned, volume percentage we learned. Now we go for the third one, mass by volume percentage. Right, third concentration. Copied all of you, got everyone same answer? Simple, no? Right. Now we go for the next one, right? Mass by volume percent. Are you following me, everyone? Mass by volume percent. You remember this is shown with the symbol in textbooks like this. W by V they show. In the textbooks when you see W by V, in exams also they represent like this. So what is mass by volume? The amount of solute present in 100 ml of solution. So right, what we define for mass by volume? Amount of substance present in how many ml, students? 100 ml of solution. 100 ml of solution. That is called what? Mass percentage. And generally, where do we observe this mass percentage? If you saw backside of tablet, see, for example, in textbooks they will show like this: 10% W by V caustic soda. What is the formula of caustic soda? NaOH. Now, what does this 10% W by V NaOH mean? Means 10 grams of NaOH is been present in how many ml of solution? This is present in 100 ml of solution. Understood? 10% W by V NaOH means what does it mean? 10 grams of caustic soda you have been dissolved in 100 ml of solution. That is called mass by volume percent. Copy that. Understood, everyone? What does this 10% W by V mean? And where do we express this concentration? Means in pharmaceuticals. You know, and the tablets, that is in drugs preparation. This is expressed in pharmaceuticals. And mass by volume percent, what we write, students? Mass by volume we can express as volume, weight of solute upon what? Volume of solution into 100. This is how we express mass by volume percent. So amount of solute present in 100 ml of solution is called mass by volume percent. Simple, understood, everyone? This you keep it in, this relation you keep it in box. Clear? Now we go for the fourth concentration. What is the fourth concentration we are having? Mole fraction. I'm moving to next sheet. Okay, students. Might we all copied this, understood everyone, all of you. So one we studied mass percentage, one we studied volume percentage. The third one we learned what is mass by volume percentage. Now tell me student, is it temperature dependent or temperature independent? See, as volume term is there, surely temperature will have influence on it. So make a note, it is temperature dependent. Are you following students? It depends on temperature. Why? Because there is volume term. Here. Now we go for the next concentration. What is the next we are having? Mole fraction. This is important, right? Heading mole fraction. Right, fourth concentration, mole fraction. Mole fraction is shown with the symbol chi. You know the symbol we represent like this. This is called chi. Now, do you heard this mole fraction in first year? I think so. You learned this simple. What is mole fraction? See, simple student. Suppose two components are there for me. A component, B component is there. Now, in this, I want mole fraction of A. See, in order to get mole fraction of A from these two components, how do I get, see, number of moles of A component? Whom else I want? That is to be taken in the numerator by total moles of all the components. What are the two components here? A and B. So what should I write? Number of moles of A plus number of moles of B. That's all. Hence, what we define for mole fraction? It is the ratio. Mole fraction is nothing but what, friends? It is the ratio between number of moles of one component by total number of moles of all the components in the solution. So what we define here, make a note definition. It is the ratio between number of moles of one component, number of moles of one component to the number of moles of one component to the total moles of all the components, to the total moles of all the components. Understood, students? So simple, it is what we define for mole fraction. It is the ratio between number of moles of one component to the total, all what are the moles present in the entire, that you have to consider. Same way, mathematically how we represent mole fraction of A, to get what do I do? Number of moles of that A component by total moles of A plus B component. Same way, tell me students, if I want mole fraction of B from the two components, how do I get? Similar, no? So what is we are taking here, that is to be taken in the numerator. That is number of moles of B by number of moles of A plus number of moles of B. That's all. This is mole fraction of which component? B component. Understood all of you? Now tell me student, does it have any unit? Do mole fraction will have any unit? No, no. Why? Since it is a ratio. So in exam point of view, they ask you which concentration doesn't have any unit. So here you write mole fraction has no unit. Why? Since it is ratio, no? So in exam they even give statement 1, statement 2. In JEE means we get statement 1 or in the form of assertion reasoning. Mole fraction is not having any unit. Is not having any unit. Why? Since it is ratio, no? No unit. Understood, student? Now tell me, is it temperature dependent or temperature independent? It will be surely temperature independent. Why? There is no volume term. So here make a note. Mole fraction is independent on concentration, on temperature. Mole fraction is independent on temperature. Following student? So this is what mole fraction. And see one more important, in a binary solution. What is binary? Two components. This is important. Sum of mole fraction of A plus sum of mole fraction of B will always be unity. Sum of the two components should be equal to what? 1. Mole fraction of A component plus mole fraction of B component will never exceed what? 1. It should be equal to 1. So this is important. Put star mark. Sum of mole fraction of the two components in a binary solution should be equal to 1. Clear for all? Everyone following Numu? Simple it is. Chemistry, if you understand, it's easy. But thing is, conceptual wise, you have to be strong and you have to be regular for the classes. Interact with the teacher. After the classes, any doubts, you have to interact with the teacher and you have to clarify. Clear? So this is what mole fraction. Hope so understood all of you. Now, see, let us take one numerical on mole fraction. Write one question. 0.6 grams urea. You know formula of urea. Urea is an organic compound. Its formula, you remember student, first year you people learned NH2CONH2. It's an organic compound farmers use for fertilizers. No, this is urea. Is present in 18 grams of water. 18 grams of water. What is the formula of water? H2O. Then find the mole fraction of urea. Chi means what? Mole fraction of urea. Copy this question. Think how you approach. Understand the question. Mass of urea given, mass of water given. And in the question is asking to find mole fraction of urea. Then how we approach this type of questions is simple. In order to get mole fraction of urea, as I told you, coefficient numerator should be taken on what else we want, number of moles of urea upon total moles. No, what are the total moles? Number of moles of urea plus number of moles of water. Correct? Now tell me student, had he given moles directly to you? So in order to substitute this number of moles, had he given moles to you directly? No, no. Then you are familiar in first year. How you bring mass in moles? To bring mass in moles, what we do? Mole concept you are familiar, no? 11th class. The given mass is to be divided with molar mass. Now find the molar mass of urea. Might be you are familiar how to find. There are 2 nitrogen, 14 into 2, 28. At hydrogen there are 4. Carbon 12. Oxygen 16. When you add total, see how much it comes. 10, 18. 18 plus 4. This is 10, 16. Nitrogen, how many we took? 28. 28 plus 4. 4 hydrogen, carbon 12, oxygen 16. Then 18, 20. This is 4, 5. 60 we have to get, see. Molar mass is coming 60. Check all of you whether molar mass of urea is coming 60 or not. Understood everyone? So in order to get moles, what should I do? This mass what he has given, that you divide with 60. Following student? The same way what I do in the denominator, the mass of urea what he has given 0.6, I am dividing with 60. And how we get moles of urea, water? Water mass is given 18 grams. So find out the molar mass of water, student. 18, this mass, molar mass also comes 18, no? How? 16 from oxygen, 2 from hydrogen. Now on simplifying, this will cancel 0.1 by 10. That means can I write 0.01 mole? This is how much, student? 0.1 upon 10. This is 0.01 mole and this will cancel by 1. And finally how much we get? 0.01 on the numerator by 0.01 on the denominator plus 1. That means it is coming how much, student? 0.01 by 1.01. Is it right? Check everyone. Or can I write this as 0.01, 1.01 as 1 by 101, student? Do you agree? So in the option, he may give either 0.01 or 1 upon 101. Or if examiner simplify this, you have to simplify and you have to check in option what will be the simplification of 1 by 101. This is how we are finding mole fraction of urea. Followed everyone? Same way, if I want mole fraction of water, if I want, tell me what should I do? We found mole fraction of urea we found. If mole fraction of water to get, what should I do? No need of calculating from 1 minus 101. Take LCM for this. This will be 101, 101 are, this will be 1. That comes how much? 100 upon 101 students. This will be mole fraction of what? Water. Clear for all? Or everyone are following what I am teaching here? Mole fraction simple, no, it is nothing but it is the ratio of number of moles of one component by total moles of all the components. So in this we get numericals in JEE mains as well as in what? NEET. And mole fraction of the two components would be equal to what? 1. It never exceeds what? 1. And it is independent on temperature. And this will be the mole fraction of urea, this will be the mole fraction of water. Clear for all? Write one more question. Question second one, within the mole fraction, see, find the mole fraction of caustic soda. What is caustic soda, students? NaOH in 40% W by W NaOH. 40% W by W. What is 40% W by W means? Mass percentage. Mole fraction of, here you write aqueous NaOH. What does aqueous means? Caustic soda dissolved in water. Think how you approach. I give you 1 minute time for you. Think. I want mole fraction of caustic soda in 40% W by W NaOH. First tell me, what does 40% W by W mean? What does 40% W by mass percentage, no students? Just now we discussed. What does it mean? 40 grams of caustic soda is present in how many grams of solution? 100 grams of solution. Do you agree, all of you? The representation 40% W by W means. But here see, aqueous is saying. What is meant by aqueous? Water. Water is the solvent. We know the solute mass, we know the solution mass. Getting idea? This is solute? No. This is what? Solution. But where we dissolved in? Water we dissolved. Now, had he given water weight to you directly? No, no. He has given only solution mass, solute mass given. Then how you get mass of solute? Mass of solvent we want. Getting idea, all of you? So to get mass of solvent, what is solvent here, student? Water, no? So what should we do to get mass of water? From solution, you subtract mass of solute. That means 100 minus, sorry, 40. That comes to 60 grams. 60 grams is weight of water. Clear, all of you? So in exam, they will represent this type of notation. That means you have to understand what is 40% W by W means. Now I know the mass of solute, I know the mass of solvent. Now in the question is asking mole fraction of caustic soda. Tell me, copy it up to here. Copy it, I give time for you and think over how you get mole fraction of NaOH. The following students, what this one what I said, 40% mass percentage is 40 grams present in 100 grams of solution. To get mass of solvent, what we do? From solution subtract mass of solute. Done. Now tell me how I get mole fraction of NaOH to get what should we do, students? Number of moles of that caustic soda by number of moles of caustic soda plus number of moles of water, no students? This is what we take relation. Now tell me, does he given any mass of solute to you? Right, see. So what is this mole fraction of caustic soda we require? No. So what we have to write, number of moles of NaOH by number of moles of NaOH plus number of moles of water. Now how many grams of caustic soda he has given? 40. So divide this 40 upon, what is the molar mass of caustic soda? You people are familiar, no? Sodium 23, oxygen 16, hydrogen 1. This is coming how much, student? 40. So getting idea all of you. This mass I am bringing in moles by 40 upon 40 plus what is the weight of water we got? 60 grams, no? From 100 when we subtract 40, 60. And what is the molar mass of water? 18. Now this will cancel 40 with one time, 40 with one time, and 3 multiple, 3 6 are 18, 3 20s are, 2 1s are, 2 3s are. That means what we are getting, 1 by 1 plus 10 by 3. Check everyone got same, take LCM for this. So that comes how much, student? 1 by LCM for this will be 3, 3 plus 10. That comes how much? 1 by 13 by 3. Or can I write this as 3 upon 1 upon 13 by 3. So this is what we are getting. Simplify, this will be the final answer. Check everyone got the same answer. That is 1 by 13 upon 3. That comes how much, students? 3 upon 13. You can put it as such or you can simplify this. This will be the mole fraction of what? Caustic soda. Clear? Suppose mole fraction of water would have been asked, what you do? From 1 subtract 3 by 13. That will be the mole fraction of water. Clear for all? So today's session we stop here. Till now what we discussed, recap at home today, and tomorrow we continue with mole fraction. Some numericals we will do tomorrow. Molarity we discuss in the coming session. Are you following, students? Everyone, is it clear? Right, I am ending the session. Bye. Wish you all the best. Right.